In this video, we're going to talk about a very specific discrete probability distribution, which is known as the binomial distribution. Binomial distributions result from the conduction of a binomial experiment, and binomial experiments have four characteristics. First, a binomial experiment will be conducted for a fixed, pre-known number of trials. So before we do this, we know exactly how many times we're going to roll the dice, exactly how many people we're going to poll and get an answer of yes or no, predetermined number of trials. We know when we hear bi as a prefix in a word, it usually means two. A bicycle has two wheels. This is binomial because each trial will only have two outcomes. This could also be a situation where we can reduce the outcomes to two categories. For example, if I'm drawing cards from a deck, I can have my two categories be a queen and not a queen. There are more than just queens in the deck, but I'm only looking at the deck in terms of two outcomes, queen and not queen. And so that would behave as a binomial. These outcomes are called success, as in the outcome of interest, and failure, which is the outcome we are not interested in. There is no value judgment here, right? This is not, ooh, I can't spell failure. Please don't judge me. Did I spell failure right? Maybe I did. It's been a long morning. But again, there's no value judgment here. We're not saying that successes are necessarily a good thing or that failures are necessarily a bad thing. Just I'm keeping track of one of the outcomes, and the one I'm keeping track of is what we call a success. Another important thing about binomials is that the outcomes of the trials are independent of each other. So if I go back to my card example and pulling a queen or a not queen, I would have to use with replacement on my draws. I'd have to put the card back after I write down what it was and shuffle the deck before I draw again. The last is that the probability of success, which we're going to call P, must be the same for each trial. That's kind of tied to the independence of the trials, right? If I draw a queen from a deck and I don't put it back, the probability of drawing a queen on the next trial will be different. So we need to make sure that the probability of success is the same for each trial. If a single trial meets those requirements for 2 through 4, meaning two outcomes, trials are independent, probability of success is constant, we call those Bernoulli trials. And Bernoulli was a famous mathematician and physicist. So repeated Bernoulli trials, a fixed number of Bernoulli trials, create a binomial distribution. Some notation before we get into math with these distributions. First, as we said above, we're going to use a lowercase p for the probability of success, and we're going to use a q for the probability of failure. And since we are only looking at two outcomes, those two probabilities should add to 1. Oftentimes in a question regarding the probability for a binomial experiment, they'll only give you P. If you need to know Q, it would be 1 minus P. If you needed to know P, it would be 1 minus Q. The other two notations we're going to see, we use lowercase n for the number of trials that we perform, and we use a capital X for the number of successes in those n trials. And when we start doing math on our calculator, it's the probability of success, the numbers of trials, and the number of successes that we will be keeping track of. All right, in our next video, we're going to talk about the mean and standard deviation of a binomial distribution, If you have any questions, feel free to drop by my Thursday office hours or send me an email. Otherwise, I'll see you in our next video.